This video we're going to talk about the mean value theorem. We're going to restate what it says, its conditions, and how to conclude and how to apply it. And we're going to apply it directly to a function, and we're going to find the c that's related to this theorem. So the mean value theorem says if f is continuous on AB, and this is the first condition, and f is differentiable, okay, that means has a derivative on AB, not including boundaries, okay, then this is the conclusion. Then there is some c. There is some c in the open interval AB, such that f prime of c is f of b minus f of a over b minus a. Okay, so now we're gonna apply it to the function f of x is the cosine of x on 0 pi over 2. Okay, so before we do that, we will see what we mean by this c here. So assume that we have some function, okay, and it's defined and continuous and differentiable on AB. So then this c, there is some c here on the graph, okay, such that f of c, okay, c f of c is part of the graph, but the derivative as at c f prime of c has the same slope as the line, the secant line going through a f of a and b f of b. So this is c, so this is f prime of c. So this is the slope, f of b minus f of a over b minus a. This is a line that's connecting a f of a and b f of b. Okay, so it says basically that there is a point in the graph which will have the same slope as the secant that goes through a f of a, b f of b. Okay, we're gonna see that for the cosine. Okay, here we want to apply the mean value theorem for the function f of x is the cosine of x on 0 pi over 2. Here clearly a is 0 and b is pi over 2 and f of x is the cosine of x. Okay, first we check the conditions. So f is continuous on 0 pi over 2. It's differentiable everywhere on 0 pi over 2, more particularly on 0 pi over 2, not including 0 and pi over 2. Therefore, there exists some c, okay? So this is the c. There is a c in 0 pi over 2, okay? That means c is not equal to 0 or pi over 2, such that f prime of c is f of pi over 2. So this is f of b minus f of a. b is pi over 2 and a is 0, minus f of 0 over pi over 2 minus 0. So here we know the derivative of the cosine, which is minus the sine, but when we evaluate at c, we're going to get minus sine of c. f of pi over 2, f of the cosine at pi over 2 is 0, minus f of 0, it's 1. It's 1 over pi over 2 minus 0, which is pi over 2. So this gives us minus 2 over pi. And with this minus, we're going to get just sine of c is 2 over pi. Okay, now to get our c, we can solve. Okay, so here this is less than 1. c is the arcsine of 2 over pi. Okay. So this is exactly, I think, 0.7, okay, in radians, 0.7. Okay, so now f prime of c, okay, gives us f of b minus f of a over b minus a. Okay, and when we graph the function, okay, let's do it graphically, that's better. So here, if we have this one, this is pi over 2, this is 1. I'm graphing the cosine of x here. So my c is 0.7, I think it's here, 0.7, and its value is the cosine of 0.7, which is 0.7, I think. So here I can say that there is a line that goes through 0, okay, through 0, 1, and 0 pi over 2. That means the secant line. Okay, this secant line will have the same slope as this point from the graph, and its slope is given by f prime of c. Okay, and it's minus, if c is, we know c, it's 0.7, it's minus sine of 0.7, and we said it's minus 0.7. Okay, and the line, we can find the line going through these 2 points is given by y minus 2 over pi x. So this is my line. So 1x is pi over 2, I have 0, 1x is 0, I have 1. So here, so this is my c. Okay, so the c that I'm looking for, okay, so the c is arc sine of 2 over pi, and the cosine of the arc sine of 2 over pi. You can simplify this cosine of the arc sine of 2 over pi. I have seen this one in one of the videos. So this is the arc sine of 2 over pi, and this is just the square root of 1 minus 4 over pi squared. Okay, so this is c f of c, sorry. So this is c f of c, okay, not c, because my c is given by this one here. C is given by this value here. So c f of c is this one here. Okay, I found my c, arc sine of 2 over pi, and it's 0.7. So this is an application of the mean value theorem, what it means, and how can we find the c that's interesting. So the c is here, 0.7. It has the same slope as the secant line going through 0, 1 and pi over 2, 0. Okay, so there is a point where the secant line and the point of the graph will have the same slope. So this is the mean value theorem. We checked its condition. We stated the mean value theorem, and this is we will see this a lot in AP calculus. So we will have to find c either by solving some equations, or sometimes graphically, or sometimes we are given the value of c and we check it. But the most important thing is we need to know what's the mean value theorem, what's its conclusion, and how to apply it. So the mean value theorem states that if f is continuous on AB, f is differentiable on AB, not including A or B, then there is some c in AB, not including A and B, such that the slope at C is the slope of the secant line going through AF of A and BF of B. Okay? I think that's all we need. Remember this one, and you need to know how to apply it. We did this one for the cosine. We're gonna do more next time. Thank you very much.